want to see how the topics that we teach will help the students to understand the algebra, which is a topic that they will study in other years. So they must have a base. They must know how the numbers works. They must understand the relationship numbers makes and shapes makes too, to then conclude how the algebra can help us to solve problems. Because at the end, algebra is one of the tools that works a lot. Okay, works many in many areas in engineering specifically. In areas like educations too, we can use algebraic formulas or algebraic expressions in order to understand the different situations of real life. For example, in statistics, we use many formulas in statistics. Those are related with the algebra. I mean, those born in algebra. So today we're gonna focus our attention in this topic of algebra. And I think that right now I'm gonna check the assistance, and I think we're gonna be ready. Just a little question. Don't know if who's using the user better Lenin Menjivar. Who really is better Lenin Menjivar?
It's the same. Karen Quiroz leave.
Okay, okay, go ahead, Karen. There you are. Good. Okay, I'm gonna check the assistants then. That way we're gonna be clear who's here. And remember there are some assistants or attendance points and some participation points. Those goes together. Okay, is Stephanie Jacqueline here? Stephanie Jacqueline? Do you know something about Stephanie? She lives in the part of the north of Honduras. We know the situation right now. It's a little bit complicated there.
She lives in La Ceiba, and I talked to her yesterday, and it was raining a lot. She told me, and she didn't have energy since 9 p.m. yesterday, and this morning I talked to her, and she told me that she was without energy still.
Okay, okay. Thank you. Thank you um, so much because you are like talking with your classmates. It's so hard, right? This situation now is so hard. So thank you so much, Mercedes. Um,
Welcome.
so now we can continue with um, Carmen Alicia.
Liz, I'm here. Fíjese que yo también estoy con eso. Aquí estoy viendo bien fuerte y ahorita pues todavía no se ha ido la luz, pero si me llego a desconectar es por esa razón.
Muy bien, entendido, Carmen. Tranquila, ¿verdad? Igual las clases están quedando grabadas y yo les prometo tratar de subirlas el mismo día, ¿verdad? Para que ahí quede el recurso. Recuerden que la clase ha ido eh, avanzando bastante rápido, entonces no nos podemos retrasar. Sí les quiero hablar de la evaluación, pero voy a terminar de chequear la asistencia. Muy bien. Seguiría en la lista Daniela.
Presente.
Muy bien. Kaylin.
Present.
Ok, Lexi.
Present.
Mercedes.
Present.
Oh, there you are. Nandi. No. Andrea Ortiz.
Andrea Miller.
Andrea
Yes.
Miller.
Yes. Here, present.
Ok. Catherine Nicole Pinto. Catherine Nicole Pinto. No. Okay, let's continue. Oh, there you are. There you are. Andrea Nicole Maradiaga.
Present.
There you are. Karen Quiroz.
Present.
Oh, there you are. Now we go with Ashley Gabriela Luque.
Present.
Ana Maria Zelaya.
Present.
Oh, there you are. So good. Give me a second. So Ana Raquel Garcia.
Present.
Thank you. Cynthia Aguilar. So there you are.
Here. Here.
So good. Marcela Yulisa.
Present.
There you are. So good. Now, Xiomara Elizabeth. Xiomara Elizabeth. No. Okay, let's go with Eunice Jaliet.
Here.
There you are. Now, Derlin Damaris.
Present.
Good. Tracy. Tracy Rochelle. No? Okay, let's go with Milagro Carolina.
Here, teacher.
Okay, there you are. So Tracy's not here. Maria Daisy Madrid.
Presently.
So good. And now Lisney Paola.
Presently.
Okay, there you are, Lisney. So I'm gonna call again, maybe because I saw somebody connect. Is Nandi here? Okay.
Lee, Nandi, I spoke to her and she told me that she was having a lot of issues with energy.
Uh-huh.
I think that's the reason.
She's right there. He's raise a hand.
Raise the hand. Okay, yes, maybe she have problems with the microphone.
Lick,
There's some
¿me
problem.
escucha?
There you are. There you are. Nandi.
No le escucho nada. Es que tengo problemas con la energía y vine a un lugar a ver si me podía conectar porque está mala la señal.
Sí le escucho, Nandi. No sé si usted nos escucha bien.
Bien poquito, Lick, como entrecortado, medio así le entiendo lo que me está diciendo.
Ok, bueno, igual después queda grabada la sesión. Por cualquier cosa usted puede volver a verla allá, ¿verdad? Igual Catherine, sí, también, ¿verdad? Ahorita estoy volviendo a llamar por cualquier cosa, ¿verdad?
Okay.
Así que tranquila, Nandi, no se preocupe. Bueno, vamos con, se conectó Xiomara, mi Xiomara. ¿No? Tracy, ¿se conectó Tracy? No, bueno, podemos empezar. So I think we are ready. With these last two elements or last two units, we want to study, of course, the algebra is another area that is very huge. Which of the two do you think is the greatest? Algebra or arithmetics?
I think that algebra.
You're thinking that is algebra. Well, which do you think is the greatest? Arithmetics, algebra, or geometry? We haven't talked about geometry yet. But honestly, because it's the oldest, geometry is the biggest. And there is a problem with that geometry that we will see tomorrow, okay? We will start talking about geometry tomorrow. It will be the last unit we will talk about it in the class. And about the algebra, well, let's see what are the basics of algebra and let's see what are the elements we may study here. Anyone want to speak? Sorry, I couldn't hear you.
Anna Zelaya, is that what was the greatest one? Is that I didn't hear?
Oh, it's geometry because it's the oldest one and because the geometry can be separated in any other geometries. That's what we will talk about next class, okay? That's why it make it so huge.
Is that when we were talking about huge, I was thinking about the content, the like how many years we have that.
No, I'm saying big, not in the sense of contents, because at the end there are things of geometry you use in algebra. So you don't know if you're teaching geometry of algebra, right? Or there are things that we use in arithmetics, for example, at the perimeter, and at the end this is of geometry, but we're using arithmetics, right? That's the little situation of mathematics that we mix all of those things. And the situation is about what it makes this huge, right? It's like the main idea. What it make it huge than the other ones? Okay, is the amount of time that people have been spending trying to understand it, okay? And it is so hard because there is the algebra, the geometry of one dimension, the geometry of 2 dimensions, the geometry of 3 dimensions, the geometry of 4 dimensions. and it goes so on. I don't know who's like with nothing to do. Nothing to do, I think so, in order to like conclude the amazing things that maybe will help us to travel to the space in the future. But right now, I think we need to solve all their problems. Okay, so let's talk about the algebra. What do we know about algebra? Let's see. So what are the objectives we are trying to like reach with this presentation? Determine the elements of algebraic expression, and then identify polynomial and variable expressions. Of course, algebra, sorry, in a simple way, is the study of mathematical symbols and properties that works for these ones. It's what we will see probably, okay? As you normally have been checking the way mathematics works or math classes works is that you study one new kind of numbers or one new kind of things, and then you see how to operate that. Essentially, this is the way how we teach or what we teach in mathematics, because at the end, those tools will help us to create strategies to solve problems, which is at the end one of the main goals of the mathematics. Okay, let's start with this. What is a variable? Here I have some ideas, and I don't know if you agree with this one or if you have another one. Totally agree? Can we understand variable just like a simple letter, a value that change? That's why the word variable, an unknown value, a representation of many values. Is there any other one? And there you have some examples, A, B, C, X, Y, Z. So totally agree with what is variable. Practically in these 4 words we have it, right? But let me tell you that variable is a concept that it's very open, but it's a concept that students develop focus in these 4 situations. First of all, when students start watching letters, okay, when they start analyzing formulas, when students see that values changes. For example, in that table of multiplication, they have one number, another number changing, but then those changes makes or has a consequence. An unknown value, when you start solving equations, and the representation of many values, well, in functions is what you do, and this is like the last form or the last thing we may represent with one variable, many things. It's so interesting. In other areas like statistics, the idea of variable works like the representation of many values. For example, we may have characteristics. And every time we do something, for example, the amount of time we see our cell phones, or the amount of time we open Facebook, will be related with one amount. And this amount will be represented with a variable, because right now I don't know that. Even you, I think you don't know that. But at the end is something that we use like this, okay? So variable is a very simple idea that we may focus on and we consider at the moment to analyze these kind of situations we will study with algebraic expressions, okay? So let's see the element of the algebraic expressions. I think that it's clear what is a variable, okay? The definition of this one is so open. Just a little interesting questions in algebra, and honestly in arithmetics too, because now the things of arithmetics become to generalize everything in the world of algebra. I mean, we can say A plus B is equal to C. But this doesn't have any sense if I don't know what is A, if I don't know what is B, if I don't know what is C. If I say if A is 7, if B is 3, then C must be
10.
10. Okay? Because these have a sense in a context of arithmetics. But right now what I'm doing is generalizing that the addition of 2 numbers is equal to another one. Maybe different, right? Is it possible that I say A plus B equals B? Is that possible?
No.
No. I mean, 7 plus 3, it's equal to 3? No, right?
No.
But Mister, what if you put the value of A to 0? 0 plus 7 will still give you
Ah,
7.
that's what I want that you see. And this is what the algebra do. Algebra tries to generalize those rules in mathematics, okay, but creating some exceptions. So what happened, or what if the value of A is 0? Then B can be any real number, and this works. So that's what the mathematics we do with algebra are about. Generalize, but generalize having clear rules. And those rules based in the arithmetics that we already know. So good, so good. You got it. You got it. Okay, it's true. I mean, there is one moment that it works. And yeah, at the end, this opened us the idea of work with functions then, but we will not do it. So at the end is the algebra. What is an algebraic expression? Let's start there. It's a mathematical sentence where numbers work with letters. Other way to see it, it involves letters in the world of numbers. So as I show you over there, I showed like the addition of two numbers is equal to another number. Yes, it's true. Or the addition of two numbers may be the same number. Yes, it's true when the number you're adding over there, or when one of the addends is 0. The combination of symbols contained in numbers, letters, and operations, of course, those are algebraic expressions. Or the representations of sentences in the math language. At the end, sentences are like a variable expression that makes operations and create something like formulas, or create a way to understand something. For example, we can generalize a list of numbers. Have you ever generalized a list of numbers before? A numbers that follow a pattern before? Have you ever did something like that? It's not clear my question. Can you generalize those numbers to 5, 8, 11, 14 that are following a pattern? Can you like create one formula that let us understand this just like with numbers and variables? Maybe. That saying no is what you were doing the last weekend with the sequences. And essentially, we were using variables over there. Not asking us like what means a variable, but at the end, we know for what is useful. Because at the end, the concept is not too much important. The use of this one is the important thing, and is like what we will focus on. Okay. So let's see what are the elements or the structure that those algebraic expressions normally have. Okay, so here we go. An example for an algebraic expression could be, it's not that all algebraic expressions behave like this one. No, this could be one example. It's like a variable having an exponent and a variable having a multiple. In this case, or a multiplier. In this case, the 3, right? So what is the 3? What is that thing that's working with the m? It's a coefficient. That's the word. It's part of the vocabulary we may know. M is the variable itself, and 4 is the exponent. So normally in variable expressions or algebraic expressions, we may see these 3 elements. A little curious question to you. Do you know what are the 2 letters we can't use in algebra? Because we can use letters of the alphabet, right, to represent a variable like A, B, C, D, F, G, all these ones, right? M, P, Q, R, W, X, Y. The X is the one that we normally use, but you can use any other variable. Do you know what are like the 2 letters that are totally like forbidden, or that are not really, that can't be used? That's the question.
Letter O.
Why letter O?
Because it looks like a 0.
Okay, because of the didactics, yes, it could be letter O. But at the end, I can use it, right? understanding as well that there's a letter O. I mean, that there's a way to write the letter O, because in some books they use it. No, it's not too common to see letter O as variable, but good observation. Is there another one? It was Eunice, right?
Yes.
Is there another one? Because I mentioned these when we talk about the world of the numbers. I mentioned that about one specific letter. Google it. Maybe you will find it. It's because Google doesn't focus in forbidden letters, because Google doesn't teach, just like shows information. No idea? Well, let me tell you that there are two letters that honestly, well, now with the one Eunice add to the list, there are two letters that honestly we may not use. Letter E, so I'm sorry, Eunice, your letter. Wow, so sorry. And letter I, those are letters that are totally forbidden for one simple reason. The letter E represents a number, and I told you that number the last class. What number is it? Do you remember? No? It's the Euler number. It's kind of like P. P is a number that we represent with a letter, but it's a number at the end. It's 3.14 and many more decimals. The Euler number is like 2.71 and many more decimals. What about the I? I is another number, but it's not a number of the ones we normally study. It's not a number of the world of real numbers we study. It's a number that is outside this world and is part of the complex numbers. So we have complex numbers, which at the end help us to answer some situations related with radical expression. We may see it here and explore or see something related with this, and you will have like a little investigation about it. Okay, so is it clear like the vocabulary we will use? We will talk about coefficients, we will talk about variable, we're going to talk about exponent. What each of these things do we have? And one more observation. An algebraic expression is not something just like that. For example, I can add another 2m to the power of 3, and this still being that this whole expression still being like an algebraic expression. But at the end, if we focus into this is an algebraic expression and this is another algebraic expression separated by the addition, we can see that it has like two elements, right? It's something we may explore in the next slides. But at the end, it's true. One algebraic expression can include the addition or the subtraction of more values. So practically here's like, what is the meaning of each of these numbers? The 3, which is the coefficient, it's multiplying the letter m. The 4, which is the exponent, is telling you the amount of times that you're repeating that letter m. And the m is the variable itself, right? At the end, we can decompose these two ways, like a multiplication or like an addition. We can write this one like m times m times m times m plus m times m times m times m plus one more m times m times m times m. And at the end, I'm representing 3 times one expression multiplied itself 4 times. So I'm summarizing an addition and a multiplication of this one. And at the end, variables can be added. Variables can be multiplied. And this is what we will study. What are the rules that work behind it? Is what essentially we want to reach today in today's class. Okay, so here comes a little challenge to you. If you have the answer, then raise your hand, please. I'm going to give you a phrase, and I'm going to give you a mathematical sentence. But I prefer to give you first the phrases and you try to like write the variable expression for each one. For example, Maria is 10 years old than Michael. If I don't know how old is Michael and I don't know how old is Maria, I think that there's a way I can represent that with an algebra expression, because Michael or Maria's years or age is something that we don't know. Okay. Carlos has double of toys of Mark's. How many toys has Mark? I don't know. And I should represent this in another way. The next one, my dad has the half of my years and 2 more. I don't know if you can represent these situations. Try to, please. Try to like write a variable expression for this one. And if you have one, raise your hand. I will give you the chance to participate. It's very interesting. I don't know. I want to hear your ideas about it. No idea? Well, is it clear what I'm asking you to do, to match those? Well, to create the variable expression, I mean. Okay, Eunice, do you have one variable expression for one of the phrases?
Maybe for the first one.
Uh-huh.
It would be 10 plus x, for example.
Okay, it could be like that. What is x for you over there?
Michelle's age, because I don't know her age.
Uh-huh. And we're talking about Maria based on Michael, okay, or Michelle. It's true. You're right. Who else raised the hand? Sorry, I couldn't see. No? So I'm gonna show you the phrase, the mathematical sentences. The phrase is already there, now the mathematical sentences. I want that you make a match. So I don't know, we already have one, I think so. We already have one, right? Maria with which one?
The second one.
With the second one. This is how you see it, right? M could represent Michael's years old. And at the end, Maria is M plus 10. If Michael is 5 years old, then Maria will be 15. If Michael is, or Michelle is 20 years old, then Maria is 30 years. So it's a very simple way to simplify something or to express something with unknowns. And this is the second use. I showed you the first use, that you can represent many variables or many things in one simple sentence with the sequences. I show you something else. We can describe a characteristic of numbers like I show you here. We generalize one operation, okay? For example, making conditions for these variable expressions. Of course, here we have variable expressions to represent real situations. How can I represent Carlos has double of toys as Mark?
2M.
2M. You say it?
Marcela.
Marcela. Okay, thank you, Marcela. It was Marcela, and here was Eunice. So I think that the only one that is missing to match is that one. So we may match that one. And everything, it's okay, right? Yes? Questions about it? No? Something that maybe calls your attention about these phrases?
Can you explain that one of my dad has the half of my years and 2 more?
How old are you? M. Okay? You're M. So the half of your M years and 2 more is represented by M divided by 2 plus 2. But I don't know. I think that you see something weird on this one. Or not?
I see something weird, but I don't know what is. That's what I have to explain it.
Honestly, I don't want that. I don't want to explain it. I want that you discover it. I want that you
I
discover it.
think the one that said my dad has the half of my years, because it should be my dad has like probably 20 years more than me or something like that. It can be just the half of, my years. My dad
So
especially.
the question is it possible? That's maybe what your brain's
Uh,
like.
It's not because,
That's maybe what your brain's like trying to solve, I think, right now. When
he's
that's
too
gonna
young.
be possible?
Too young.
It was possible in Benjamin
be-
Button.
Okay. In that movie, yes. In
Probably-
Hollywood, everything is possible, I think so.
yeah, probably if the son is born before the dad,
Is that possible? Okay, so I think, yeah, I was wondering, you see something weird over there and you got it. So good, Andrea. But it's at the end an impossible thing. But if you see, even if it's impossible, we can represent that mathematically. Now, what will be an answer for this? Maybe, listen, maybe a very small number that doesn't have any sense. And maybe you're going to say then that if you are 20 years old, then your dad is 12 years old. It doesn't have any sense. What you maybe will discover is that probably there is a number that make it works. And this makes something like the exercise I asked you at the beginning. Can a number added with another number be itself? Yeah, when the other number you're adding is zero. So that's what the algebra focus on, situations like this, to discover it and see if it's possible or not. And based on that, you create a rule, you create a formula. Okay, so that's the amazing part of the algebra. But at the end, well, be careful with situations like this ones, right? You're so logical, and I think that, yeah, that's why you were like, something's happening there. That's true. It doesn't have any sense. So in each of the expressions, we should understand what the variable m represents. And I think we already say that. For example, in the first one is Michelle's years, okay? In the second one, the amount of toys that Mark has. And the other one, the age, okay, my age, how old I am, which is something impossible, of course. So here we go with the next part. The main idea of algebraic expressions, it's like determine those properties in a general way. So we can use variables to demonstrate or to show that really two properties work without doing like a real proof of all the numbers. If not clear what I'm saying, I'm gonna show you one simple example. So we can apply those expressions to create general rules for real numbers. So we can generalize the arithmetics essentially. And that way we can eliminate the uncertainty of, is it possible that something works? I mean, is it possible that my dad that my dad is the half of my years and 2 years more? Is it possible? Well, with the algebra, we may discover that. Of course, those rules are based on algebraic expressions, not on numbers. That's the situation. Now we're going to generalize those numbers as one expression, like we did it with the sequences, and we may understand those situations in a different way. It's so interesting, the algebra, okay? So do not believe that one rule will work for every number. That's another situation, just because it works with two numbers. Like the addition of two numbers is always 5. Yeah, because 3 plus 2 is 5 and 1 plus 4 is 5, and that's it. But what happened with 1 and 3? Or what happened with 2 and 4? Okay, that's what the algebra tried to answer. Here's an example. Here's one idea, my hypothesis. The product, the multiplication of two even numbers, oh sorry, the product of an even number with an odd number is always an even number. Can you give me an even number, please, and then an odd number to try? Can you give me?
12 and 7.
Which
12,
ones?
12 and 7.
So then 12 times 7, it's equal to an even number. What is 12 times 7?
84.
It's 84. Ah, 84 is an even number. Can you give me another one? Can you give me another even number and another odd number?
2 and 5.
2 times 5, which is 10, which is an even number. It looks like it works, but is that enough to you? I mean, do you believe that's true? Or is there a number where maybe this will not work? Well, the way to be sure about it is prove it. At the end, we create something that help us to demonstrate, which is one important part of the mathematics, the proofs, that will help us to conclude if this hypothesis I do is correct or not. So check this out. If I prove this for natural numbers, okay, with n working as natural number, check this out. And yeah, this is like pure mathematics, so don't worry about it. And essentially, I'm saying this. All the even numbers should be written like 2n. So any even number can be written like 2n. Working n as natural number. Like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If you replace those values here instead of the n, you will create an even number. Like 2, 4, that's a sequence. I think we know how it works. How can I represent the odd numbers? Well, the odd numbers should be written like the even number and one more, because at the end, all the consecutive numbers of even numbers are odd numbers. I mean, what is the consecutive number of 6? What is the number next to 6?
7.
7. So then 7 is an odd number. Based on that, I create an algebraic expression to represent those. I think you know how to do this. It's something we already did. I mean, if I have the sequence of 2, 4, 6, 8, 10, and so on, you can make that rule to make this work. What happens if I have, well, let's see, 1, 3, 5, 7, 9, and so on? You can create a rule to solve it, okay? So at the end, check this out. I'm gonna not try with numbers as much as I can, because you can make a list of thousands of numbers, of million of numbers, and multiplications like this ones, trying to see if this one is always even. So math properties should be established or proven with algebraic expressions. And right now, here is the reason, or here is the how. If I multiply these ones, and don't worry about a multiplication right now, I will explain you this later. We will have here the product of those things. 2 times 2n makes 4n to the second power. Then 2n times 1 makes 2n. If I look for the way to rewrite this expression like 2 times something, which at the end is like the general form they have, the even numbers, it will work. And yes, it works. I mean, essentially, I can take out here the 2 as common factor, which is something we will see later, or if you don't get it, okay, because the topic right now is just show you that I can prove it. Essentially, I can rewrite these 2 times, well, what happened with the addition of 2 natural numbers? Because at the end, n squared is a natural number, because it's a number multiply itself. It will be a natural number because of closure property. And if I add another natural number, this will be this a natural number? The question is n squared plus n a natural number or not? Okay, so here we will make another proof. Honestly, yes, because of closure property, the one we used the last time. So at the end, we make another natural number, and twice a natural number is always an even number. So I already prove it. I already demonstrate this without trying number by number. I do it in general, if you see. So that's what the algebra tried to helps the moment to create properties. And essentially, many of the properties, for example, the properties of the GCF, the property of the least common multiple, are related with one analysis based on algebraic expressions. So these, for these are useful, the algebraic expressions, okay? So here we go. Okay, try next property. The addition of an even and an odd number is an odd number. How even numbers are, we say? And how odd numbers are? How are the even numbers? Yeah, you can give me a list of even numbers, 2, 4, all these ones, but I want that you tell me in general how they are. How can we represent them?
By natural numbers.
And how?
With the n.
Just the end, just like that?
No. With the double line.
Double n, so 2n, like that.
No, a double line for the n.
Oh, the natural numbers, that's what you're saying. No, I'm asking you for like, how can I represent any even number? Like 2n. Here we have it. How can I represent any odd number? Like 2n plus 1. Well, I'm telling you something. The addition of an even number and an odd number, is an odd number? Is that an odd number? I mean, let's see if that works. I don't know. Give me an even number, give me an odd number. Just to try it.
The even number can be 4 and the odd number can be 7.
Okay, if I add an even number and an odd number, I will get 11 in this case, which is an odd number. Oh, it looks like it works. Can you try with another one? Or can you tell me another combination of even and odd number to see if it really makes an odd number? Any even number, any odd number?
2 and 3 would give you 5 and it's still odd.
Okay, 2 and 5, which will give us 7, still odd. 2 and 3, that will be odd, another odd number. So do you think this works? This always works? Next property that I like create, or because I think it will works? Yes, it's true. Well, the way to be sure is mix those algebraic expressions. I mean, find the addition or try to add those algebraic expressions that I have. Is it possible to add algebraic expressions? Well, I don't know, but maybe you know that. What will be the result of 2n plus 2n plus 1? What do you think it will be? Maybe you know that. Well, I'm checking if you know something too at the same time. No idea? Have you ever added variable expressions before? I think that yes. Well, essentially, a question. What is 2 plus 2? Sorry, but what is 2 plus 2?
4.
It's 4. So essentially what I have over there is 4n plus 1. Now, we say that the addition of those even and odd number that I have here, the addition of any even number and the addition of any odd number will make an odd number. Is this an odd number? Odd number looks like 2n plus 1, but I have 4n plus 1. Maybe if I do some tricky things over here, like play with the numbers, and instead of work with 4, I work with 2 times 2n plus 1, it maybe will looks like what we wanted. Now, what happened if I have 2n? I will have even numbers. So no problem at the end because are numbers. So at the end, I have 2 times another number. We can call it like c, okay? Because at the end, you're going to have a number over there plus 1. Will help us to make or to create another algebraic expression which looks like this. And at the end, it's true. We can say that the addition of an even and an odd number is an odd number. And it's not that we will try one by one these cases. No. It's that we will look for the way to find it and generalize these ones, okay? So at the end, this is one of the objectives of algebra, as I told you. Generalize the geometry. Generalize the arithmetic. Well, even the geometry too. Even part of the geometry have been generalized with simple algebraic expressions. So those algebraic expressions are so powerful, I think so. And here we go. Well, if there's any idea or any question or any comment about this first part of the algebraic expressions, is it clear what an algebraic expression, for what it's useful, what can we do with this ones? We can generalize things. That's like the main idea. Instead of being working specific cases, we can say in general, it will works like next. So questions? No? Okay, so let's go now to the world of the polynomials, which essentially is the first part of algebraic expression. Look, the world of algebraic expressions then opens new necessities like study functions, like study calculus, but of course, it's just like algebra right now. Then opens, that's why we teach like that too. That's why in first, third, fourth, fifth grades, you focus a lot in arithmetics, not too much in algebra. Just in sixth grade, I think you start talking about a little bit of algebra. Okay, let's talk about polynomials. What do we know about polynomials? You maybe will say that they are not useful for anything. No, they are useful for many things. So, what are polynomials? Listen, are variable expressions or algebraic expressions working with natural or whole number exponents. That's an important definition. And separate by additions and subtraction. Okay, so practically we may see many of those things like 2n to the power of 7 plus 5n, I don't know, something like that. We may see expressions like that one, which at the end will help us to understand a polynomial. But we cannot understand polynomials if we don't understand monomial. What is a monomial? Essentially, it's like the basic element that makes polynomial works like they are. Monomial, it's related with one. Polynomials is related with many. That's why the word poly. A monomial is an algebraic expression with next characteristics, and I think we should take note of next. First characteristic, let me zoom in here, is that a monomial contains variable or variables, more than one, okay? It has normally one coefficient, which is normally a real number. Here you can see a 3, here you can see a negative number, here you can see a fraction. And the exponents, as we say, work as whole number, because they cannot work in another way. I mean, you cannot work fractional exponents, you cannot work negative exponents, because at the end is if they represent other thing, okay? At the end, be careful with this simple idea. Monomial contains coefficient, which is a real number, variable or variables, and those variables has exponents, which are whole numbers. And essentially, these elements will give the characteristics of the monomial, which at the end will help us to understand the characteristics of the polynomials. And here we go with something some of those characteristics. Depending the amount of monomials that are separated by additions or by subtractions, you can build one polynomial. Of course, poly means many of these ones, many monomials, right? And we can name the polynomials, listen carefully, because the world of polynomials, it's so huge, but we can name polynomials depending the amount of terms they have. For example, there you have like a little situation. If it's just one element or one term, you're talking about a monomial. If you have two terms separated by addition or subtraction, then you're talking about a binomial. If there are three, so a polynomial, a trinomial, sorry. If there are four, normally this is called like tetranomial because of the number four, tetra, but at the end we can call it like polynomials, right? And then if it have five, it's called pentanomial, but in general from four and beyond, we call it like polynomials, many monomials, as we have it over there, okay? So let's see here. I will appreciate if you tell me, well, first of all, raise your hand and you tell me the name of next polynomial. What will be the name of next polynomial? If it has four terms?
A polynomial.
A polynomial. But if we have the specific name, it could be called like tetranomial too, right? That is just like a polynomial. You're right. What about the next one?
Binomial.
It's a binomial. Okay. And the last one?
Trinomial.
It's a trinomial. So as we can see here, it's so easy to identify when something behaves like this. Let's see. I don't know. One more example, because maybe somebody has a question. If I have like 2m to the power of -2 plus 7m, how this one is called?
Binomial. I know it has a negative, so it is not.
So it is not. Essentially, one situation like this breaks apart the idea of polynomial. And yeah, maybe you're saying, but the 7m is not working the negative sign. Yeah, but all that thing is one thing. Yeah, I know you're watching over there two things, but those things are joined by this addition symbol. So at the end, expressions like that one create this ambiguity, but at the end, it's not an ambiguity. I mean, there is a rule that we have to respect, and is that the exponents will behave always as positive numbers or whole numbers. Right now, I have a negative exponent over there. So what is this? It's not a polynomial. So what is it? If it's not a polynomial, what is it?
A binomial.
No. I mean, it's not a polynomial, so then it's not a binomial, it's not a monomial, it's not a trinomial.
Algebraic expression.
It's not a polynomial. It's just an algebraic expression. That's what it is. Okay? Essentially, that's what it is. All those, it's true. All those, this one, all algebraic expression. This one too. But this one has something special, that they behave like the separation of monomials. So you're talking about polynomials. It's clear the idea of polynomials, because do not think they are the same. Algebraic expressions are kind of algebraic expressions that we may study to understand the rules or the ideas that works behind the world of algebraic expressions. Is it clear? Yes? Okay.
Yep.
We can go next slide. There are some elements the polynomial has. The first one is the degree. When we say that degree is not master on, right? That degree is related with something easy to see in monomials, but in polynomials, we must focus in each of the monomials that makes the polynomial works. Well, essentially, a polynomial is a degree of a polynomial is given by the greatest exponent of the variable, or listen, or by the sum of the exponents if you have more than one variable. Be careful with this. The sum of the exponents, if you have more than one variable, but this happens in a monomial, okay? In every monomial, that's what you should analyze. In every monomial. What about that leading term? The leading term is normally the monomial with the greatest degree, the leading coefficient. The leading coefficient is the coefficient of the leading term. And finally, there is one important element that is called the independent term. And it is called independent term because it is not affected, or it's normally not affected by the variable expression, okay, or by the variables. Normally, this is just a number. Okay, so as we saw, depending the amount of terms or the amount of monomials one polynomial has, you can name it in different ways. Now, depending the degree of the polynomial, those receives different names too. Here comes like the first one. If the degree is 0, then it is called like constant. If the degree is 1, then it is called like linear. If the degree is 2, it's called like quadratic, then cubic, then quartic, then quictic, and then it's called the 6th polynomial, the 7th polynomial, okay? So next one will be like 6th, 7th, and so on. So write the name of next polynomials. We already know this was a polynomial. It receives like one name. But I think that now we can name it, or we can put the other name it has, or the last name it has. What is the degree it has, do you think? What do you think it is?
Cubic.
Excellent. Degree is 3, right? So let's talk about the degree. It's the greatest exponent right now. The greatest exponent is 3. And it's not the sum because you're not working with different variables. You're working with the same variable x in every of the monomials. So the greatest is 3. It means that my degree, or the degree of that polynomial that I have right now, is 3. So then it receives the name of cubic. And we can specify this. Cubic because it has more than 3 terms, or more than 4 or more terms, cubic polynomial. We can specify it name. What about x to the 4th and x to the minus 25, x to the 2nd power? What it will be? What will be the name? So first of all, what is the degree of this one?
4.
It's 4. So what will be the name it receives?
Quartic.
Quartic. Okay? Quartic. So it will be called like quartic because the degree is 4. Quartic. But more specifically, quartic what?
Binomial.
Excellent. Quartic binomial. What about the last one? Degree is, well, is 2, right? Is the greatest.
Quadratic.
It's called quadratic, okay?
Trinomial.
Excellent. It's the quadratic trinomial. You're right. And this is how it works. Let's see, and I think I can make some more questions. I think we are clear with the degree. Don't know if of the first polynomial that I have here, could you tell me what is the leading term? What is the leading term of the first, of the polynomial that I have over there? of the cubic polynomial that I have? What is it?
The 2x.
The 2x to the power of 3. The whole expression, right?
Yes.
This one. This is my leading term. What about of the other one, the x to the power of 4? And but what about the last one, x squared? So, seeing the other definition or watching the other definition that we have, what is the leading coefficient of the polynomial?
3.
Is it 3? Is 3 the coefficient of the?
Oh no, wait.
So what is it? It's 2. You're right. Nice. What will be my leading coefficient here in x squared, in x to the 4th, I mean?
1.
Well, even in x squared, we don't see it, but there is a 1. It's true. That's so good. You got it. So normally the number not shown over there is 1. Reason is, how many x to the power of 4th do you have over there? 1. You don't need to show it, but it's over there. Last question. What is my independent term in the cubic polynomial?
The -10.
The -10. That's my independent term. What is my independent term in the quartic binomial?
0.
Excellent. There is not, so we should represent that one like 0. And in the last polynomial?
9.
It's positive 9. Okay. So then question to you. How can you call this polynomial? There is no variable. Nope. Well, there is any variable. There's a little problem with this one. Normally, many people get confused. 5 is just a number. Is that an algebraic expression? You don't see the variable there, but there is a variable, let me tell you. So which one do you think works for this specific case?
It would be the constant.
It is the constant. And essentially is, because here we can work with any variable we want it to the power of 0. Do you remember the properties of exponents that works for the real numbers, for example? Because I saw in one of the forums, nobody focused in exponents. And you have many properties with exponents too about real numbers. Okay, you can look over there on internet, please. What means raised to the power of 0? Raise any number to the power of 0, well, excepting the 0, who has...
it's equal to 1.
It's equal to 1. So essentially you have 5 times 1, which is 5. Okay? So constant are practically independent terms that are working with any variable exponent 0. It's always like that. There is a condition for this one. And is that x cannot be 0. Who has an iPhone here? Who has an iPhone? Could you ask to Siri, what is 0 divided by 0, please? Because she answers so funny that. Just let me tell you first. Not 0 divided by 0. Well, yes, it's the same. 0 to the power of 0 is equivalent to the problem of 0 divided by 0. So you can ask, could you ask to Siri this, please, Elisa?
What do I ask? What's 0 divided by 0?
Yeah. Okay. And if you can play the what she said, it will be okay.
Hey, Siri. What is 0 divided by 0?
If nothing is divided by nothing, then there's nothing to divide, or divide it with, and the division never happened. So my answer is no.
Wow. I think your Siri has a new actualization. But last time I hear it, It's like compared like the amount of cookies I have to divide with the amount of friends that I have. I have no cookies and I have no friends. City says. I don't know, something like that. It makes it so funny, but como dice aquel, salió guaya. I don't know if you ever hear it about, but it's so funny. Maybe I will share to you the video because it's so good. Well, so this is what we have about the polynomials. They have some elements. Depending the elements, they may receive a name. They may receive another classification too. Well, those are ways to classify or name the polynomials. And at the end, it's so important that we specify their names. Is it clear, like, what are the elements the polynomial has? The polynomial has, sorry. Is it clear?
Yes.
Yes? Okay. So just to be sure, I want that we, right now, identify the elements of those polynomials that we have. The degree, the name. When I say the name, the complete name, right? So I need the degree, the leading coefficient, and the independent term. For example, let's start with this one. What is the degree?
2.
2, because it starts with number 2 or because exponent is 2?
Because the exponent is 2.
Okay, thank you. So this is my degree. So then, because it's degree 2, and I think you already see how many monomials you see over there, what is the name it receives?
Quadratic trinomial.
Quadratic trinomial. Okay, let's see. What is my leading coefficient?
2.
It's 2. Oops, sorry. Yeah, that's my leading coefficient. Coefficient, sorry. That's a pronunciation, right? What a weird word. Okay, and let's go now with the independent term. What will be my independent term?
Negative 10.
Negative 10. Okay, so now we have here the other polynomial. Can you tell me first what is the independent term?
Negative 11.
Negative 11. It's so easy to see. So we can call it like the IT, the independent term. Can you tell me then what is the name of this polynomial? What is it?
A quintic polynomial
Why?
because it has 5 terms.
Because it has 5 terms, it's called polynomial. And why quintic?
Because the biggest exponent is a 5.
You got it, you got it. Don't know if you see it, because maybe you're watching the 3. But the greatest one is this one. At the same time, this is my degree of the polynomial. And yes, it is called quintic. And quintic because have 5, and then because you have more than 4 monomials, it's called like polynomials. So then it's missing one more thing. What is my leading coefficient?
1.
It's 1. We don't see it over there, but there is a 1 working like your leading coefficients, okay? So I think we're clear with the element of polynomials. Be careful. If the polynomial is in disorder, there is another situation you may solve. You can reorganize and change the order of those, respecting always the sign. I mean, we can rewrite this polynomial like x to the power of 5 because it's the leading term, always at the beginning, and then the rest of them, but following an order, depending of the degree the monomial has. For example, the degree of this monomial is 3. So it is next one, because there's no exponent 4 expression over here. So we may go to the next one. There's a little jump, and then we go to exponent 3 expression, which is next one, the negative 2x squared. And the last one, well, there's no last one yet, plus 6x minus 11. This will be the right way to write it, okay? It's a common problem that maybe students don't respect because they don't see the importance of show the first monomial at the beginning. And it have a sense to be at the beginning. That's why it's called like the leading monomial, okay? So when we talk about polynomials, we must keep in mind about those elements. And I think we are ready to see what happened with next expression. Next algebraic expressions are not polynomials for simple reason. I already explored with you this idea. First of all, for example, here I work with a negative exponent. Sorry, this is not a good color. It is a negative exponent. The other reason, for example, why this makes not works as a polynomial, because the x is in the denominator at the end. This represents x to the power of -1. So again, a negative exponent. If you see here, there is another problem. You may have roots working with a number, but not with the variable. And if you see here, you have a exponent that works like a fraction. So fractional exponent. That's why it doesn't works like a polynomial. Of course, the definition of polynomial says that are monomials working separated by addition and subtraction. And we say that the definition of monomial is variable expressions with exponents that works as whole number. 2/3 is not a whole number. Okay, so it is a fractional exponent. And let me tell you something interesting. Maybe you don't know that, but this expression like the cubic root of x is equivalent to have x to the power of 1/3, which means roots at the end behaves like exponents. Okay, this is so important. It's a little weird thing that we normally don't see, but in the world of exponents, which is related with exponential expressions later, it's so important. Of course, the algebraic expressions we may do will focus on that case of polynomials, okay? So we're gonna start in our next part of the class with the polynomial operations. We may talk about next operations. Of course, there are some conditions that works behind it. There are many relations that we may study, and at the end there are functions that we will study too, and those will help us to understand another world of expressions later. Of course, algebraic expression is so huge. That's why I'm starting with the first initial part, the polynomials. There are 4 basic operations that works in polynomial. I think you know what they are. Talking about addition, subtraction, the multiplication, and the division. And I'm gonna work those just like one. Because at the end here, we will summarize into just join one kind of expressions. And then we will study the multiplication. And I think in the part of the division, we will explore something interesting, which are like 2 interesting methods to make polynomial division. But it will be when we come back from our break, okay? Because we have almost 6 o'clock. So I think that we have, yes, we have the break until 6:30. So see you in 30 minutes, okay?
Thank you. See you.
See you. 30 minutes. If you want it, you can stay, connect to the meeting, no problem. That way you don't get lost, the connection or something. Okay, see you.